Everyone, it's Jorndorf, and I'm going to try and solve day 14 of this year's Advent of Code. To start with, I've just got an empty terminal and an empty Python file. Let's get going. Chocolate shards. You have a chance to look at all the produce moving around. They're making hot chocolate. They're maintaining a scoreboard which tracks the score from 0 to 9 of each recipe. Alright, only 2 recipes are on the board. To create new recipes, oh, it's this genetic algorithm sort of thing. 2 elves combine their current recipes. This creates new recipes from the digits of the sum of the current recipe's scores. Okay. Okay, alright, so far so good. 3, 7, 1, 0. Alright, after all new recipes are added to the scoreboard, each elf picks a new current recipe. Moves forward a number. This is just kind of crazy. Okay, so after the first round, the first elf moves forward 1 plus equals 4 times. They run out of recipes, they loop back around to the beginning. First elf is parentheses, second elf is square brackets. They just go like nuts. The elves think their skill will improve after making a few recipes. However, that could take ages. You can speed this up considerably by identifying the scores of the 10 recipes after that. For example, if the elves think their skill will improve after making 9 recipes, the scores of the 10 recipes after the first 9 on the scoreboard would be this. After the first 9? After the first 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that's not it. What does that mean? If the elves think their skill will improve after making 9 recipes, the scores of the 10 recipes after the first, this is 9 of them. Yeah. Okay, great. What are the scores of the 10 recipes immediately after the number of recipes? I'm a little like not following here because what? Okay, so they think their skill will improve after making this many recipes. I want to identify the scores of the 10. They just added this list, and then the next, so the slice from this number to this number plus 10 is the answer. Okay, great. All right, so let's see. This is kind of weird. It's not a genetic algorithms thing. We're just gonna start with, I'm gonna call this function f, because last time I lost a lot of time trying to rename that function, and that was stupid. So it's a number and not a string. These are the positions of the L's. First elf is on 0, second elf is on 1. Those are pointers into the recipes array, right? And then what we'll do is we'll just, so that we add all of them together, is that right? So we add the current recipe scores. Okay, great. So let's see. The sum of the scores of the current recipes is the combination. And then you convert that to a string. And for each character in that, you add that digit. All right. So actually, I feel like I should make this a a function. But let's take a look at the thing. So the new recipes are added to the scoreboard in the order they're created. After all new recipes are added, then each elf picks a new current recipe. Great. So so I'm gonna make a step function where you put in the recipes, you put in the current positions, and then out comes new stuff. First, so I'm going to do this. This is a Python thing. It means you don't modify the incoming list. You just you create a new list and add it to it. And this will be slow if we do a billion of them, but a couple 100,000 should be fine. So, well, actually, you know, the famous last words, but we'll see. So then the elves move. So each elf starts with each elf steps forward to the scoreboard. Rubber recipe is equal to 1 plus the score of their current recipe. You know, it doesn't really say, but it feels like eventually they will land on the same recipe, and then they'll be on the same recipe forever after that. Doesn't that seem like it'll be the case? I mean, I don't know. I don't know what's preventing that. It seems pretty random where they will end up. And let me read it again. After all, if they've run out of recipes, they loop around to the beginning. Does not say anything about them avoiding each other. So it seems inevitable that they'll just end up in the same spot forever. Oh well. Well, let's just do it. So let's see. Positions equals. So for each position we already have, we're going to compute a new position, which is something modulo the number of recipes we've got now. And what is that? That's going to be I plus 1 plus the current recipe, right? The current score. Therefore, what we think is that if you start with 3, 7, 0, 1, then you'll get 3, 7, 1, 0, and 0, 1, right? And then if you do it again, then the parentheses guy will be on number 4, and the other guy will be on 3. So let's try that. And then we'll worry about F later. Let's just give it a shot, because, uh-oh, I'm in the wrong place. Silly. Okay, so those assertions passed, and everything's good. Great, so then now here's our starting position. I guess I don't really actually need to go quite this far. I can like divide by 2, and then that will produce a puzzle input. So then I need to add like 5 to that. Right, because each generation we add 2 new recipes, and so we need at least 10 after the ones we already anyway. So we'll try it that way. And then. What are we doing? We're returning the recipes in positions. Let's say like instead of like that, yeah. So right? So if they think they're going to improve after 9 recipes, then the answer will be, actually, let's join all of these as strings. So F9 is going to be this number right here. Ooh. This number right here. We've got a bunch of examples here, but I mean, it seems kind of weird to be typing these in, but let's just try that. Float objects. Oh, right. So I'm using Python 3, so I need to tell it explicitly to round down. Is that good to round down? Maybe I need to add one more. So let's just do that as a sloppy thing. Oh, great. Okay, so Okay. So for some reason, this divided by 2, rounding down would be 2, plus 6 is 8, and I didn't actually do 8 of these. Did I, like, what's going on here? I obviously don't need, oh, right, here we go, okay, great. Now, the question is, why is that? Like, doesn't it increase by 2 each time? No, it only increases by 1 each time, and that is because you add 2 numbers together, and very often the answer is a single digit. Yes, got it. Okay, great. So I don't need to print anything anymore. And I'm passing assertions, so I'll do one more. Oops. One more after 2018 recipes. You should get this number, and then print f of 40950 puzzle input. And it takes a long time. It's because of that stupid list extend thing. I'm not, darn it. Well, should I plus equals here? It doesn't really hurt anything. So I don't have an answer. I think this will still pass tests. It's weird. Ooh, still bad. That's kind of strange. Oh, I didn't say it. Okay. Mutability for performance. Go on to part 2. As it turns out, you got the else plan backwards. I actually want to know how many recipes appear on the scoreboard to the left of the first recipes whose scores are the digits. How many recipes appear to the left? Okay, great. So, I mean, the best way, we're going to save this in a new file. The best way to do this, I think, is to just assume, so how many, so puzzle answer, I need to find this random pattern. Wow. A random number is not going to appear super fast. I have to assume it's not random, right? If these happen to be equal to the target, but if this is the case, then we need to do that. I do 2 because I can have a 2-digit number and add 2 recipes in a single round. And then I just keep going like that. I don't need to index, so I just keep going. And then, yeah. So now the deal is like this. 51589 first appears after 9 recipes. And we'll try that. Part 2, please. So this isn't good. Let's see what it's actually trying to do. Target. Oh, okay, so assert syntax error. What did I do wrong here? Oh yeah. Okay, so the assertion passed. I don't know where my remaining print statement is. Okay, there we go. All right, what are my other assertions? I can assert these other things. But maybe I should just make a go for it. Make a go of it. Let's just try. Object is not iterable. Convert it to a string and go. Meanwhile, I can work on just in case. I can open a new tab and see if it gets past the assertions. It does. Taking forever. I mean, there are faster ways to do this. I could optimize, but it feels like it's just going to take forever to get there. I wonder if I do a version of this where I'm like, I wonder if a pattern will emerge, right? So let's see if I print the new ones. Oh, it finished. Go, go, go. That's the right answer. We got it.